Alright guys, we made it to the last question of paper 1 of the November 2018 South African CAP syllabus matric mathematics paper 1. Right, so this last question is another probability question just like the previous one, and we need to solve just 2 questions. Alright, so let's just get right into it. Now first we get given in 12.1, we get given that P of A, the probability of A is 0.45. We get given the probability of B, let me just write B is Y. Okay, so that is an unknown. That's a Y. And then the probability of A or B is 0.74. Alright, so the question says determine the value or values of Y, so we need to solve for Y, if A and B are mutually exclusive. So what does it mean if A and B are mutually exclusive? Well, that means that the probability of A and B happening at the same time is 0, right? So let's look at the examples. This is the last question. We're going to spend a little bit more time just going through some of the theory. So for something to be mutually exclusive, we can think of an example like heads and tails. Let's just circle that. So what's the probability of throwing heads or probability of throwing tails? Right, so the probability of getting heads is 0.5 if you flip a coin. If it's a fair coin, right? If you want to go gambling, you don't want to use a fair coin, you want to cheat, obviously. Again, and the probability of getting tails, 0.5. And the probability of getting anything else, 0. And the probability of getting both heads and tails in one flip, that's not going to happen, right? You either get a head or a tail, you don't get both. So that's mutually exclusive, and this is what this will look like. So there's no overlap between the two. Now, let's think about rolling a dice. And let's say, what's the probability, or we want to look at all the prime numbers, probability of prime numbers, and we want to look at even numbers. So if I ask, what's the probability of rolling a prime number? Well, then you write in all the prime numbers, which is 2, 3, and 5, are all prime numbers. Even numbers, 2, 4, and 6. Alright, so we see there's an overlap. You can get a number that is both a prime number and an even number, and that'll be the number 2. So if we go back to this first question, the probability of H or T, that's just equal to the probability of H plus the probability of T, right? Heads or tails. So you either get a head or a tail, there's no other options. And that'll be equal to 1. So the total probability will be equal to 1, just because there's also no probability of anything else happening. This equal to 1 is not really the issue. What we want to focus on. Let me write down this formula. The basic formula for probability. The probability of event A or event B happening is the probability of event A happening plus the probability of event B happening minus the probability of event A and B happening. Now why do we minus that? Well, let's look at this as an example. Right. So we had the probability. So let's just do this. What's the probability of rolling a prime number or an even number? If you roll the dice once, what's the probability that the answer or the outcome will be a prime or an even number? Well, we can count everything that's any of those, right? 1, 2, 3, 4, 5. There are 5 values that's either a prime or an even number. How many total values are there? Well, the number 1 isn't included here, so the head has to go there. There are 6 numbers on the dice. So we get 5 out of 6. Now, let's see what would happen if we said probability of A plus probability of B and we didn't put this in. So what's the probability of P by itself? Probability of rolling a prime number. 1, 2, 3 out of 6. 3 out of 6, right? And the probability of rolling an even number? 1, 2, 3. 3 out of 6. 3 out of 6. Now if we just added those two, we would have 6 out of 6, which would be 1. Which would make it so that if you roll the dice, you're certain to have a prime number or an even number, which is not true because you can also get a 1. So we see here, we need to include this because what happened? We counted the prime numbers, 3, 5, and 2, and we counted the even numbers, 4, 6, and 2. So we counted this number twice if we just do that. We're counting the intersection twice. So we have to subtract it once, so that means we only counted once. So that's why this formula works, and especially where this part comes from. Just so we don't count the intersection twice. Alright, so a bit of the background on the theory there, so let's do the question. Okay, so our question actually was this one here. we need to find the the value of y. So we're going to use this formula, this basic formula. So the probability of A or B, we know that's 0.74, 0.7. Actually, let me write down the just 12.1 so we know what question we're busy with. Probability of A or B, that's 0.74, right? Plus, well, not plus, equals, okay, right? That's that, equals, then the probability of A, we know that's 0.45, plus the probability of B, which is Y. And then minus the probability of A and B. Now, what did we just say? If things are mutually exclusive, like heads or tails, there is no intersection. The probability of A and B. So for mutually exclusive, probability of A and B equals 0. Right, so that's the thing to remember here for mutually exclusive. So minus 0, so we don't need that. Now we can just solve for y straight away. So 0.74 minus 0.45 equals y, and that just gives us 0.29 equals y. Actually, let me just check the calculation. I'm a little bit rusty at the moment with mental calculations. 0.74 minus 0.45, 0.29. Okay, great. So that is the value of y. Now, question 12.2. 6 marks. That looks like a tough question. Let's have a check. Okay, so question 12.2. Let's read. Okay, I'm actually just going to get rid of some of this here, just so we can read a little bit better. All right. So in an organization decided to distribute gift bags of sweets to grade R class at a certain school. There is a mystery gift in exactly a quarter of the total number of bags. Okay, so a quarter of the bags have a mystery gift. Each learner in the class may randomly select 2 gift bags of sweets, one after the other. So first selects one bag and then another one. And the probability that this learner selects 2 bags of sweets with a mystery gift is 7 over 118. And we need to find the number of gift bags that has the mystery gift inside. So we need the number of mystery gift bags. Okay. So there's a couple of things that make this difficult. One, it's quite a tough question. Conceptually, you have to think a little bit. You can't just plug and play and solve. Or at least you have to know what to plug and play before you can solve. Secondly, it's a lot of reading. So you forget what you read in the beginning, in the first sentence when you get to the last sentence. So let's just write down a couple of things. So we have a certain number of bags, and a certain number of those bags contain a gift. So I'm going to say let the mystery gift bags be X. So those are the ones that contain the mystery gift. So then the total number of bags would be what? Because the mystery is 1/4 of the total, right? So the total number of bags would then be 4x, right? The total number of bags. Just put bags here. Mystery bags and total bags. Okay. Now, once we've set something like this up, now it becomes a lot easier because we at least have something to work with. You could have also said 1/4 x and x, right? It doesn't matter. I just like whole numbers, so let's go with that. Now, we've covered that part. Now, a learner may randomly select 2 gift bags of sweets, one after the other. So what they want to do is they want to select one bag and then select another bag. So I'm just going to draw a tree diagram to represent this information. Right? So this will be the first bag and this will be the second bag. Okay. Now, let's say at the top, most likely is they're not going to get the mystery sweet, right? So how many bags? So 3x out of 4x bags will not contain the mystery gift. So we don't really care about that. We care about this. X out of the 4x bags will contain the mystery sweet, or will be a mystery bag. Right? Now, we want to say, we know that the probability of selecting both mystery bags is 8 over 117. So we want to find this other branch as well. So now the learner selected one mystery bag, so now there's one less mystery bag to choose. Right? So x minus 1. And there's 4x minus 1, one less total bag, so 4x minus 1 here. And now once we've set this up, now it's an easy question. The difficult part was probably just to name it x and 4x for the mystery bags and the total bags, and then just to think about it this way. And to include the x and not just the 1 over 4 and then the next part, right? So it's 1/4 of something and 1/4 of something, right? So let's continue. Now we know that we multiply along the branch just to get to our answer there. So we'll just say this times this equals that. So the difficult part is over. Now it's just back to algebra. So we're going to say the first bag, let's just actually write this down exactly what we're doing. So the probability of getting a mystery bag and getting a mystery bag is equal to 8 over 117. Right, the probability of getting the first bag being a mystery bag, that's going to be x over 4x. And so we multiply. The next bag is a mystery bag, so that's going to be x minus 1 over 4x minus 1 equals 8 over 117. Great, now it's just straightforward algebra from you. So what I'm going to do, I'm just going to first multiply the left-hand side out to make it look a little bit simpler, although it's already quite simple. I'm going to actually multiply that. Maybe it looks less simple after that. So x times x is x squared. X times negative 1 is negative x. Bottom, 4x times 4x is 16x squared. 4x times negative 1 is negative 4x. Equals 8 over 117. And I'm just going to cross multiply. Now why does cross multiplication work? It's not just some magic trick. We're just saying we multiply both sides by this denominator, which will get rid of it on this side, right? And it'll add it to the top there. Then we multiply both sides by this denominator to get rid of it. So it'll get rid of it here and add it to that and multiply it on that side. So we're just doing that in one step. That's cross multiplication. So we're going to say 117. Is that 8 over 117 correct? 7 over 118. I thought I read something different here. 7 over 118. Let me just correct that before we get to the wrong answer here. Okay, so 7 over 118. 7 over 118. Well done if you picked that up. That's a common mistake people make in mathematics. You don't read your questions, and probably in all subjects. 118x squared minus 118x equals 7 times 16. What is that? That's 112, right? 112x squared minus 28x. Minus 28x. All right. Now, what do we have next? Now we just want to get everything to one side. Let's 118x minus 112x squared is 6x squared. Then negative 118x plus 28x is minus 90x equals 0. So we can factor out an x. What's left? 6x minus 90 equals 0. So we get either x equals 0, and that's obviously not going to work. There's not 0 bags. We know there are some bags. Or 6x equals 90, which means that x equals 90 divided by 6, which is 15. So there are 15 mystery bags. Right, 15 mystery bags, so that would mean 60 total bags. So the scenario is probably there were like 30 kids in a class, and each of them gets to choose 2 bags. Right, so that's why 60 bags. So it seems like a legit real-life scenario. Okay, I will admit this last question was a bit tricky to set up. Let me know if you did it a different way, if you use something other than x and 4x, or just because there's probably quite a lot of different ways we can solve this. Let me know in the comments below, and we can definitely discuss some alternate methods of solving this question. Or if you have a question on some of my explanations, which I might have gone over too quickly or not done well enough. Alright, so that was it for this question paper. Hopefully I'll see you again for another one.